I'm assuming that somebody will quickly read out Dr. Valsa's profile. I will refer to a couple of personal things only. My association with Valsa. Though I also served in ISRO for about 10 years. My association with Valsa started much later with the professional societies only. And both of us were resources person for an event in CSI, Computer Society of India. I think possibly IEEE was also a joint host of.
Yeah, co-sponsor.
Yeah, and also Valsa once she was invited when I was heading that group there to address our young women engineers. I think here a lot of women are there. She addressed them. How women can manage the, obviously compared to men, women have more challenges managing home and professional life unless you do have a very strong supporting family behind you. So there is a big challenge, but how one will manage both, I think that's a remarkable talk. I will always remember that. And that one line, a lot of young girls are here around. I tell you that one liner only what Valsa said that day. Good. You never seek a concession because you are a woman. Amazing line of what she said that day. And there are other reasons also for me to be excited when Valsa is around. And she is an alumni of 𝗶𝘀𝗲𝗄𝗏 College of Technology, Coimbatore. And she did her graduation in electronics communications from 𝗶𝘀𝗲. And I was in the Board of Studies of Computer Science for about 20 years in 𝗶𝘀𝗲 Tech. I think longest serving Board of Studies member was me.
Okay.
And in addition to that, for the team here, there is one of the very, very senior leader in Tata Group who was a COO of Tata Powers, and now he is still a director in Tata Board, Mr. 𝗜heç𝗱𝗶𝗶. This 𝗜heç𝗱𝗶𝗶 was classmate of Valsa.
Not classmate, sir. He was 2 years my senior.
2 years senior, yeah.
But I knew him while in college. Yes.
And 𝗱𝗱𝗶 was also very excited when he knew that I know Valsa and we are working together in the professional space. After several years, again now IEEE has given an opportunity for me to connect with Valsa. Thank you, Valsa, for your time.
Yeah, thank you for inviting me, sir. I should say that. See, you remembered and you invited me, so I'm very honored to be here. I think we need not have any long introduction. We can start, or is it there, Lisa?
Anyway, your profile has been shared. If somebody has planned the talk, we will go ahead with the talk.
Yeah. Shall we?
Lisa, madam?
Yeah. Sharath, 1 minute, Sharath. Hello, Prabin. Anybody is?
Okay. I will briefly tell a couple of other things and then we will hand over to Lisa, madam. See, for example, Valsa has been instrumental in many things in ISRO. One of the recent thing I tell you, which will be exciting for this group, the Mars mission, right? The onboard software was cleared by Valsa. Her team cleared that, which studies the Mars environment. So that as latest as that, Valsa was there as part of that, clearing the onboard software for that mission, Mars mission. And second thing I want to say, recently ISRO has got into relaunchable vehicles, right? There also Valsa has a major role. And some of the technology feasibility had been already cleared by Valsa when she was serving for ISRO. I think these two at least I will say to tell you Valsa is current, not past. Now it's hand over to you.
Okay. So
see, I know you heard it by heart, so I don't need anything to read.
Lisa, shall I start or?
Yes, madam. Okay. Hello.
Yes, madam. Start.
Okay, madam.
Okay.
Hello, ma'am.
Yes.
Shall we start the session?
Yes,
Yes.
yes.
Yes, yes.
Okay. Greetings. Good evening, everyone. I trust you are all doing well and ready for an engaging session. I am delighted to extend a warm welcome to every one of you on behalf of the IEEE Education Society Kerala section. Today marks the second episode of our talk series, ProTalks, where seasoned professionals provide insightful talks about their respective fields. We have the privilege of hosting a session on Indian space research, a brief insight and career opportunities by Dr. 𝗬𝗏𝗏𝗏, who is a seasoned aerospace professional responsible for quality assurance in avionics, mechanical systems, chemical and propellant, and software for launching vehicles. Known for meticulous attention to detail and strong problem-solving skills, Dr. 𝗬𝗏𝗏𝗏 ensures the highest standards are met for mission success and safety. For many of us, space has always held an undeniable fascination. But this session is about more than just the cool stuff out there in space. Dr. 𝗬𝗏𝗏𝗏𝗏 will give us a guided tour of ISRO's amazing work. We will learn what the Indian space research is all about and the incredible achievements so far accomplished. She is also here to make us aware of the awesome career opportunities you can have in the field, drawing from her extensive experience and expertise.
Okay.
Now, we are having a short profile of our guest, that is Dr. 𝗬𝗏𝗏𝗏𝗏 ma'am. Dr. 𝗬𝗏𝗏𝗏𝗏 is an outstanding scientist and former deputy director at Vikram Sarabhai Space Center. With a career spanning over 3 decades, she has been a pivotal figure in ensuring the quality and reliability of ISRO's launch vehicles, including PSLV, GSLV, GSLV Mk3, and reusable launch vehicles. Dr. 𝗬𝗏𝗏𝗏𝗏 had led teams, contributed significantly to the Mars mission, and established a world-class independent verification and validation facility for evaluating flight software. Her contributions have been recognized with several awards, including the IEEE Outstanding Women Engineer Award and the India Today Women Scientist of the Year Award. Dr. 𝗬𝗏𝗏𝗏𝗏 is a member of various professional bodies and has made significant contributions to the field of aerospace engineering. Now, without further ado, let's welcome Dr. 𝗬𝗏𝗏𝗏𝗏 to share her expertise with us. Over to you, ma'am.
Okay, thank you for that lovely introduction. So shall I go ahead? I think I'll be very briefly touching upon the ISRO, because ISRO by itself is a very big topic. So I'll just, my presentation will be something like evolution of VSSC, evolution of launch vehicles, launch vehicle design and flights, satellite application, some missions of ISRO, and space transportation, what we are looking forward, and quality as a tool to sustain the reliability of the launch vehicles, then job opportunities, starting your career, and summary. So first, this is what I planned. And before formally, I would like to thank Dr. 𝗂𝗏𝗏𝗏𝗏𝗏 and Mrs. Lisa for inviting me for this and sharing my thoughts with you. So first, let me start with a salute to the Doyen. See, you all know Vikram Sarabhai. He's the father of the Indian Space Research Program, and he's a multifaceted personality. He was an institutional builder, industrialist, educator, research scholar, like ISRO, one institution, then IIM in Ahmedabad, Physical Research Laboratory, PRL, Electronics Corporation of India, you name it. I think he had built more than 50 institutions. So he was a visionary with interests varied from science to sports to statistics. And he has been the chairman, member, advisor of international scientific committees. So we have to thank, because at that point of time, to think, see, we have just come out of the British rule and we are just reeling under the economic crisis after that and all. And at that point of time in the 60s, to have a vision to start an Indian space research program. And let me tell you, most of our launch vehicles are cost effective. If you compare with what the cost of NASA, ESA launches and how we do our launches, it is very cost effective. So that also we could do it because of this great person's vision. And his vision was, if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the realization of advanced technologies to the real problems of man. And we have been able to solve a lot of things. I'll quickly give you when I come to that. Okay. So this is looking at India. You can see, you might have heard of many centers, but I think only the prominent centers you would have heard: Trivandrum, Bangalore, Ahmedabad, then Chennai, in the sense Hyderabad. But we have so many places. Just to show that we are distributed, we have might be sometimes small units only, but still we have a lot of places where we have our centers and units. So now, Vikram-Sarabhai Space Center. See, I was in Vikram-Sarabhai Space Center, and it is the lead center for space transportation systems. See, we focus mainly on research and development endeavors. And you can see, these are all entities, all the bubbles which are doing aerodynamics, mechanical, propellant, space ordnance. Space ordnance is the pyro systems, which will ignite the stage or separate the stage. Then there are chemicals where the propellants are made. Then integration and testing, mission design and simulation, control and guidance, avionics, so many are there. So all these efforts lead into our program. These are the, now small satellite launch vehicle is the latest one which we have developed. It is a small satellites because see, 3 days only it will take for that launch vehicle to be made ready, and it can be launched from a mobile launch pad. So that is launch on demand. That is the mantra, because it can be used during a war or during a specific time you want to get a map of a particular area. A small satellite can be launched and you'll be getting details. Then PSLV, Polar Satellite Launch Vehicle, GSLV, Geosynchronous Satellite Launch Vehicle, then GSLV Mark III, then Human Space Program, Air Breathing Propulsion Systems, Advanced Technology Vehicle Program, RLV Reusable ACE. These are some of the things which are there. And human resources in VSS is something like 4,635. And out of that, something like 4,070 are technical. So I'm telling you this number so that you know how many technical people are there. So now you can see the main reason why it came to Trivandrum was the Earth's magnetic equator passes near to Tumba. It's a fishing hamlet near Thiruvananthapuram. And at that time, there was no building. There was only a cathedral. The St. Mary Magdalene Church served as the office and laboratories. And the bishop's house was the office. And from there, we launched our first Rohini launch vehicle. Small. It went up to an altitude of only 75 kilometers. And first launch was a Nike Apache, which was a rocket from US, which we launched. But that was in 63. And in fact, we had an anniversary celebration, 50 years, 75 years, I think. Yeah. 60 years, we had a celebration in ISRO for that. And you can see some of the pictures, actually, who is sitting, the two people who are sitting at the bottom and filling, the launch vehicle, small propeller rocket. First one, can you guess who it is? It is Abdul Kalam. And the other is Dr. Arwa Mudan, who is supposed to be known as the quality guru. And you can see the launch vehicle evolution. You can see from here, like we had SLV-3, which is only, say, height 22.7. And then we had augmented satellite launch vehicle, ASLV, then PSLV, then GSLV. And you can see the left-hand side, you can see it's a 12-story building. So to give you some idea of how tall these launch vehicles are, it is like something like 40 to 44 meters tall. And the lift of weights also I have given. And we have combination of propellants like solid propellant, liquid propellant, and cryo propellants. So that also I have given, but maybe it will be too difficult to assimilate all these things. And the satellites orbit, that LEO means low Earth orbits, and then GTO means geo transfer orbit. So PSLV is the most versatile one. It can launch both SSPO, that is sun synchronous polar orbit, as well as geosynchronous transfer orbit. So that is the one which we used for our Mangalyaan, that is the Mars orbiter mission, and for our first Chandrayaan. So it had done all work, and so many launches we have had. And the spaceport of India is Sriharikota, Satish Dhawan Space Center. And its advantages, we can have an eastward launch. So the rotation of the Earth can aid the rocket in gaining some velocity. Now, this is just to give you a feel of the rocket assembly. See, you can see this, the launch. This is the fully assembled launch, and we have different bays and platforms which will allow people to stand nearby and assemble. And there are huge cranes. And you can see that this is the launch pedestal on which the first stage is being lowered, and then the interstages, and all these strap-ons. So many things are. So it might look like stacking a cake, but it's not a cakewalk. Okay. So this is to just give you, see, if you see the size of the person standing by and the size of the interstage, it's only a interstage stage between two stages. Like we have, PSLV is a 4-stage vehicle, GSLV is a 3-stage vehicle, and Mark III is also, we can call it as a 3-stage vehicle. So each stage is the one portion of the vehicle which will burn and then get separated. We don't carry dead weight. Once our use of a stage is over, then we don't carry it. And you can see this is the satellite assembly. This here, I don't know, the satellite can be seen. This is that is the heat shield which will protect it while traveling through the atmosphere, and later you discard it so that you don't carry another unnecessary weight. And this is how stages are being taken. Just a quick look so that you'll get a feel of it. And behind it, you can see the mobile structure and the heat shield being closed. And then we have a tower moving back. This is the mission control center where we all will be sitting just before the launch. And this is PSLV, you can see. And it has lifted off. And watching it live is a very good sign. And this is the trajectory. Trajectory is the path it takes. We have video cameras on board which will show the satellites. We had launched 108 satellites and created a record, and that is the visual of that. This is GSLV. And this is the Mark III. You can see the size. It is like a sturdy fat boy. And this is the reusable launch vehicle. And this is re-entry of the CARE module, which is a first step towards human space program. These are the future ongoing missions which we have. And in fact, on March 22nd, we had a reusable landing experiment. That is also to prove technologies for human people to go in a space capsule and come back and land safely. So these are the applications. You see the telecommunication, TV broadcasting, search and rescue, and satellite news gathering, radio networking. And in fact, even fishing, see, a small thing, even in 𝗬𝗏𝗰, in Trivandrum, we have a port where from the satellite, they'll get the images about where fishes are available. So the fishermen need not go aimlessly. They can go where the shoals of fishes are available. And similarly, that cyclone warning and all that helps in reducing casualties. You know, earlier days, many people used to die. I think now we don't hear of anyone dying unless we can move them to a safe place. And we have our own satellite navigation system, IRNSS. And only thing is, like it will be like our GPS, but we have got a semiconductors complex limited in Chandigarh, which is in the process of developing a chip which can be used for in our mobile for using that. So it will help us because we need not depend upon GPS and all that for going anywhere, but it will be covering predominantly India only, not all the entire world, but and some section of the Asia also. And remote sensing applications, see, so much data is coming, how it is being used. For that, we have a center dedicated, National Remote Sensing Center, and they have developed a 𝗏𝗏 software, which is like Google Earth, and you can use it and see because it gives a lot of data. And the address is there, http://bhuvan.nrse.gov.in. Please take a look at it and see what all it offers. Disaster services, ocean services, weather services, mapping services, lot of details are there. So now, looking at the missions of ISRO, see, PSLV, I told you, is the most versatile vehicle. Because where does it versatility comes from? From the multiple satellite in a single mission, different orbits. Like you can inject one satellite in one particular orbit and then travel some more and then inject it in some orbit. So PSLV-C35 was a classic example, and PSLV-C37, in which we launched 104 satellites and created a record. And this number has increased again. It's not 59 missions. 59 missions was in September 2023. I think 3 more launches had happened. And multiple orbits, as I told you, lunar and planetary, upper stage orbital platform. Now what we are doing is, PSLV is a 4-stage satellite vehicle. So each stage is there. And the first 3 stages, once they are burnt, they're discarded into the sea. We have an impact trace point, IIP trace. So we ensure that it doesn't fall into places where people are living. We'll ensure it will fall into only sea, which is not in damage, which will not cause any damage to any passing ships also. And we have the 4th stage, which will be rotating at a different orbit from the satellite. So after a long time, it will die down. So space debris is a very big problem, because all the burned out satellites and the upper stages of these rockets will be there. So what we thought was, while some fuel is remaining for it to sustain, we can use it as an experimental platform and get some data. And some experiments have been carried out regarding the inertial navigation systems, whether when it moves, like what are the data happens, how it behaves and all that. And some other experiments has also been done. So typical satellites which PSLV had launched is MOM, Mars Orbiter Mission, then Cartosat, which is used for mapping, then Astrosat for astrology and all those details, METSAT for meteorological applications, SRE Space Recovery Experiment, and IRNSS, which is our own GPS, Aditya, latest one. So this is, and specific characteristics are, it is robust, reliable, and cost-effective. And commercial launch satellites from other places, some 297 satellites from 33 countries we have launched. And actually there is a video in this, I don't know whether it will work. Okay, SRE videos, yeah.
The re-entry of a capsule commences with the completion of the de-boost operation. Traveling at a velocity of 8 kilometers per second, the entry of the space capsule into the Earth's atmosphere generates tremendous amount of heat caused by skin friction. The temperature experienced is in the order of 2000 degrees centigrade at the nose cap and 1400 degrees centigrade on the silica tiles. About 5 kilometers above the sea level, the 3 parachutes in SRE open up sequentially at prescribed altitudes. The parachute system is meant to reduce the touchdown velocity approximately from 100 meters per second to 12 meters per second at the final touchdown. With touchdown, the parachute gets detached from the capsule and flies away. Subsequently, a float gets inflated that keeps SRE adrift. After the helicopter located SRE, a team of divers from the Indian Coast Guard took over and recovered the satellite.
And in fact, this space capsule which has been recovered is available in our space museum. I showed you a church in the beginning, where it first started. There, if you go, you can see this recovered space capsule. And this was the first step for our human space program. That is, this capsule coming back safely without any damage, and it gives us confidence that we can send crew also and get them back safely without any problem. And this was done some 10 to 15 years back. And this is GSLV Mark II. See, initial GSLV, we used cryo stages from Russia, but we developed the capability for launching communication satellite and cryogenic propulsion technology for upper stage. And it is a lift-off mass is something like 416 tons, and we can put see, the efficiency or the capability of a launch vehicle is measured in terms of the payload. Payload is the useful mass which can be used, which will carry the transponders or the cameras and all those things. And GSLV can carry something like 2.2 ton. So our ultimate aim is to have some launch vehicle which can carry 4 tons to GTO. Then only we can reduce the rendering other transponders from foreign satellites. So this is Chandrayaan Mark 3, which was used for Chandrayaan 2 and 3. See, you can see the Chandrayaan mission. See, you put it this all for thermal protection, and see the heat shield, and you're checking whether it is compatibly when you mount it. And you can see the orbit. See, this is something like this. Like, see, you start with a small orbit, then you come to one point and fire a small rocket, and make the ellipse bigger and bigger, and then you go there and around the moon. You first initially you have a bigger orbit, and then you reduce it, and finally you go to the lesser orbit where you want it to be. And these are known as earthbound maneuvers, and we had 5 numbers. And here's the some details about how this was assembled. Why I'm adding the videos is, without video or pictures, if I tell something, you might not be able to visualize it. See, this was Chandrayaan 2. This is animation, okay? This is what that part, but where it was injected was actual photograph. So now space transportation way forward. This was the technology evolution stage, and these have now all been stabilized. That is PSLV, GSLV, and Mark 3. And this is the small satellite launch vehicle which I have told you. And this is the Gaganyaan, that is which will send human beings. You can see the crew module. It will be situated here. And this is the orbital reusable vehicle which is still being designed. And the heavy lift launch vehicle is 8 to 10 ton payload. I told you, the useful part which we can use is known as the payload, and which is capable of launching. See, first I'll come to that launch vehicle design portion. I'll come. I don't know whether I'll have time, but I'll quickly run through how it will happen, and that design phases and designs aerodynamic studies are going on now. See, this is the small satellite launch vehicle. 2 has been tested, and first one slight problem was there, but the second one has been a great success. Launch on demand. Only 3 days will require to set this up, because the motors they're all solid motors, and they'll be cast and kept ready. So low-cost launch vehicle, on-demand launch capability, and minimum launch pad occupancy. We can launch it from Shar, or if you have a mobile launch pad, you can launch it from anywhere. That is the advantage of this. And this is the reusable launch vehicle. See, you can see this how it lifts off, and different stages are getting separated, and finally, like an aeroplane, it looks like that, and it comes and splashes into the sea. And this is the visual of the reusable launch vehicle. First, we had an technology demonstration program. Then we have had that was HEX, then LEX landing experiment. For that, we have taken this launch vehicle, the small reusable launch vehicle, in a big helicopter. That is, it will be carried by some harness, and it will be released, and it travels some 4 or 5 kilometers and comes and lands exactly at the place where we wanted it to. That you can see. The landing experiment is here. You can see it's in a helicopter. It is taken and it is dropped, and it comes and lands precisely. So we were testing our navigation, guidance, and control algorithms. And this is a typical mission profile for the orbital reusable vehicle is something like this. And see, space application and societal services. This is something many people question us. We are a poor country, why we are spending money on space. But this helps us a lot, because so many, as I told you, the applications are many, and then if you don't run the transponders, you save a lot of money. And we do it in a very cost-effective manner, and it carves a dish for India for interplanetary explorations. See, we were the first persons to find presence of water on moon, and we are still getting postcards from the Mars. Like, I didn't add those slides. Even now it's working, though we expected it to stop working after 2016-17, it's still working. And low-cost access to space is our mantra. We are able to do that, self-reliance in space transportation. So this visionary's vision has been fulfilled to a great extent, and we still continue, ISRO still continues to fulfill that. And Gaganyaan, as you all know, it will be the first flight mission of ISRO will be by 2025. The astronauts who are flying, I think the 3 people have been introduced by the Prime Minister. They have undergone training in Russia. The life support system and flight suits are ready. And there are human sciences and bioastronautics also. Those people are also very much relevant than engineers. And this is the crew module. Actually, in Human Space Flight Center unit, which is there in Bangalore, there is a model, and you can see the 3 beds sort of thing in which the astronauts will be traveling in. They will be lying down while when it is taking off. After that only they can move around. And that has also been done. So we have 2 unmanned flights by 2023 and 2024 was what is planned. And 1 we have done in 2024, and one more will be there. And 3 astronauts will be traveling for 7 days in space. There is so many things are there. ECLSS is the most challenging thing because there will be sweat and excreta and all those things, and we have to have see that it is done in a very cost-effective way, and that and all we are developing ourselves only. And the space suit and special simulators are required for that, and the crew escape system. In case something goes wrong, they should be able to eject and go. That is there. All these things are new. You can see new is there everywhere. Nothing is there which is existing, except, and the human rating of the launch vehicle is very challenging because it is not like sending an unmanned rocket, because there are so many things, and the security, safety, and the reliability has to be to a very high level, because you cannot take chance with human lives, and that is very challenging, and ISRO has geared up to that. And in fact, I've been able to standardize the software, because the software is the one which will be controlling all these things. The software standard to be followed, to what level, so that we can be certified and we can say that it is safe for a human, that is human rated, it is safe for a human to travel in that. So this is the crew escape abort system has also been demonstrated by 1 flight. That was what we did in 2023. We have aborted and seen that when people are there and something goes wrong, and if they abort and if it doesn't abort, that is a serious catastrophe. So that has been tested and it has been working well. It worked well. So we have confidence for our mission. Then I'll tell you about quality assurance of launch vehicle. Why quality is important? Because, see, ultimately, as Deputy Director of Systems Reliability or Quality, I have given clearances for 40 missions. So there, before the launch, we have a meeting called the Mission Readiness Review, where all the senior people of different centers will be there, and all will be waiting to see whether the presentation is only from the quality people. And I had given for the launch vehicle side for 40 missions and given the assurance that there are no problems. So giving a statement like that seems simple, but it cannot be done just like that. You have to do a lot of work. I had a team of some 200 and odd people who used to go through meticulously through all the test reports. And for software, we ourselves used to test it. And for the avionics, electronics part, we have a T&D team who used to test it. With all that data and compiling and going through it meticulously, you give the confidence that this launch vehicle can be cleared for flight. Based on our assessment only, the MRR, Mission Readiness Review team, gives the clearance for that. So after that, there is no further checks. So once that is done, and if anything fails, the first person to be questioned will be the quality assurance person. So, and I'm very thankful to God that during my tenure, there had been no failures, and everything has been successful, and there was no issue. So why? So quality is very important. Why quality is important is because space technology is complex. It is highly multidisciplinary. All disciplines of engineering and all maths, physics, chemistry, of all sciences, everything is there in space. The technology, state of the art, and it is a strategic technology, high degrees of accuracy and precision, and severe environmental conditions, the vibration, the temperature, and all the disturbance that comes, shock, all that it has to withstand. And there are some non-testable elements also, because see, pyros, for example, we cannot test it. We take a batch, out of 20, we test 2 or 3 sample-based testing, and we say it is okay. Because pyros, once tested, it cannot be used. So there are non-testable elements like that also. And space is very unforgiving. A small deviation or bug in even one of the thousands of elements, subsystems or software can cause a catastrophic mission failure. In fact, in 1993, our first PSLV was launched was a failure due to a simple, what you can say, floating, simple overflow error. That is, the number exceeded the value that can be represented by that byte or 16-bit word. So it is very important that there should not be any problem. And quality is never an accident. See, the quality, if you have to have sustained, successive, successful missions, you have to have a quality system. Quality is never an accident. It is always the result of high intention, sincere effort, intelligent direction, and skillful execution. It represents the wise choice of many alternatives. There might be many alternatives, and in that you have to choose the right one wisely, and not based on feelings or thing, based on data. So we have done the QA activities for the entire launch vehicles, like from the aerodynamic studies to the structural testing, avionics parts testing, propellants and pyros, composite structures, onboard and checkout software, checkout and integration. And apart from this, we compile non-conformances and lessons learned, because this is very important, because failures are always stepping stones to success, though people say, and it sounds like a cliche. It is not so. We have learned valuable lessons from our failures. So then QA people carry out the verification testing, audit, follow-up, review, recommendations, and so on. So current QA scenario is there's a strong quality system catering to QA of software, mission, avionics, mechanical systems, composites, chemicals, and propellants. This is an avionics. Avionics is an electronics package, and this is a part of the pyro. So the culture that has been built from the 70s, ISRO had a quality culture. That is because we had a management commitment. The management was, see, quality cannot survive in an environment where the management does not support it. So there was management commitment and there was independence. You don't report to the designers, you report directly to the director of the center. So you have independence and professional attitude, acceptance not based on schedule or cost. It is based on technically whether it is right or wrong. And integrity of the personnel and documentation is important. Prevention and continuous improvement. Objective evidence, nothing is subjective. Everything has to be in black and white. And identification and traceability is also very important. So strength of VSSC or ISRO is, now this is not about quality person, I'm saying in general, the clear responsibilities and authorities are there, leadership with profound knowledge, well-defined management system, and review mechanism. I will say, if in 2 words I have to say what are the strength of VSSC or ISRO, I will say the review system and the teamwork, because nothing can be done by a single person, because the flow starts from the beginning till the end, and it is a teamwork. And openness across organization. In a review system, there is no restriction that a fresher cannot ask a question or a junior person cannot ask. Anyone can raise a question, and that freedom has helped a lot, because sometimes thinking out of the box questions comes from the youngsters, because we are so tuned to something, we might not be able to see the obvious. Sometimes these youngsters have come up with very good questions which has helped us. Then adequate communication and transparency and quality function independence, and we are certified to a quality management system. See, a quality management system helps us to put a framework in place which helps us to carry out the quality function. So I'll say experience is a hard teacher, because she gives the test first and the lesson afterward. See, when you say we have experienced failures, but after the failure only we know that it was a failure. So I always say that experience is a hard teacher, because she gives the test first, which you fail, and then only you get the lesson afterward. And we have had so many systems which might not have resulted in failures, but at the launch pad, just before reaching the launch pad, on the launch pad, we have seen so many things. Like during preparation of space systems, encountering problem is normal. Some systems were there, but we missed them. Sometimes overlooking happens. Missing is due to lapses in review, lack of analysis in test results, lapse of quality in fabrication and inspection. Why I am telling you all this is, this is applicable for you wherever you youngsters are going to work also. See, only thing is in space, we cannot recall the product back. Once it is gone, it's a failure. For you all, if you are working in an IT or in some fabrication or some other area, if some warning symptoms are there and you miss it, if you can, it is possible to repair it back later on if you encounter a problem. But sometimes it's not possible. So that is why I'm saying the consequences of missing warning signals are disastrous, and not missing the distress signal at the right time is a major quality challenge. That is where the quality people in ISRO are taxed, because we should not miss it, because immediately, how did quality miss? That is the first question that comes. So PSLV flight in September 93, which we had, the flight was normal till end of second stage. You can see this is going like this. This was the expected, but the top curve was what was expected. But what happened is the vehicle deviates. Once it starts tilting, it brakes, and we lost control. See, it was an overflow in digital autopilot software causing the sign reversal of the pitch control. Like we have 3 controls: pitch, yaw, roll. That is in 3 axes. So the third stage controls capture time only this happened. So what happened when the sign reversal happened? It aided in the direction of the error, and it resulted in positive feedback and vehicle tumbled. This similar signature was encountered in one of the pre-flight simulations. So no proper analysis. People thought we had one angular motion simulator, AMS we call it. It was something to do with that, and people ignored it. Okay, people did think because all other cases went through, only one case failed, so they attributed it to that. So all subsequent operations in flight was normal, and simulations showed mission success, but the costly lapse of achieving the success in first flight was missed. We had achieving first success in very first flight, we missed it. It was a costly lapse. Similar problem was encountered in Ariane, which is the French ESA's flight. Exactly similar problem, and that could have been avoided. If we had looked into it, we could have learned from them. So from that, we made a total cultural change. That is why I have written in my biodata also, independent verification and validation. A lab was set up for the first time in ISRO, and under the leadership of Narayanan sir. And we are some 3 or 4 of us were only there, and we did the clearance for the next mission, and it was a total success. And you can say the success, see, the gap between success and failure is 1 mm. Can you believe it? See, there was in GSLV F02, there was a dimensional deviation in the propellant regulator of L40, that is a strap-on engine. 17 mm it was in place of 16 mm. But this was not missed. It was seen by the quality control inspection. They thought 1 mm, what difference it can make. They wrote it down and they did not escalate it up. So people up, the senior people were not aware of it. So when the launch took off, uncontrolled flow of propellant came and the mission was lost. So it shut down prematurely and the vehicle broke up around 59 seconds, causing mission failure. So nothing is trivial in space. You cannot ignore anything. That is the message I want to tell you. See, the first miss was during dimensional inspection. Second miss was during the flow test of the regulator. Our dimensions which are functionally critical are identified and checked twice independently now after that. Then we have a quality management system. This latest version we have been certified, and we have around 400 internal audits and 50 external audits. And the task set to ISRO people is 0 defect. See, at least 0 defect in the operational phase, that is plus minus 3 sigma. So meticulous inspection and quality control of critical components are sacrosanct. For every test, define robust evaluation method. And whatever is given in yellow is from which mission we learned these lessons. Analysis of the result of each and every test needs serious attention. PSLV D1. Test result of a critical component is to be compared with the template of or earlier results. Like that, we have so many lessons learned which are documented, which any fresher who comes can go through, because it is there available in our intranet, and they don't make the same mistake again. And I told you about the multi-tiered review mechanism. These are the design review teams, then the flight readiness review, then the mission readiness review, which I told. And once that is there, the launch authorization board clears and we have the final launch. And we have a system of calculating the reliability of the launch vehicles. And you can see that we have designed the PSLV for a launch reliability target of 0.64. First one was a failure, so the reliability got down. Then afterwards, we have come to that, and you can see there has been only an incremental increase. 0.967 becomes 0.973. Here, there was a handling error. That is why the reliability came down. And these are the different configuration, the full vehicle or the core alone mission and all that. So now launch vehicle design, if you take, these are the different elements. See, aerodynamics and thermal, configuration design, pressure load distribution, multi-flow. This is done predominantly by aerodynamics engineer and mathematics people, as well as structural people, okay, and mechanical people. Here, structures and materials done by materials engineers and structural people. It can be in a mechanical with a structural specialization, or a civil engineer with a structural specialization who does all this. Then propulsion mainly done by propulsion, because MTechs who have done specialization that, and mechanical engineers do these design. And once the propulsion is designed, the structures people design the structure for that. Then navigation, guidance and control. Here, predominantly electronics people, as well as control and control systems people are the people who play a main role. And vehicle integration, electrical as well as mechanical engineers are there, and stage auxiliary system and avionics, also electronics. So the majority of the people in our ISRO, VSSC, are mechanical and electronics. So now I'll come to opportunities for engineers in space. I'll say ISRO is an ocean of opportunities, because all, I told you, multidisciplinary, almost all branches in engineering, mechanical, aeronautics, chemical, electronics and communication, structural engineering, computer science, with a sprinkling of civil and electrical. They are mainly for our building and that wiring and all those. So all branches are people are employed there, and basic sciences like mathematics, physics, chemistry are also required in space research. In fact, we have a space physics laboratory itself, comprising of some 50 people who do exclusively studies what all experiments they want to conduct in the space, and chemical people are there who study on the propellant compositions and what we should do, and mathematics people who study about how to avoid collision of the debris or the vehicle with the debris and all those things. And there is an applied mathematics division itself. So engineers in space, no gender discrimination at recruitment. Merit is the only criteria. Career is challenging with opportunities in new development in innovations, because every mission is a new one, and always we have to do some innovations for that. And work demands precision and excellence, and hence there are work pressures to meet schedules, and overall you have to be, overall expertise is a must. You cannot be lax and think that you cannot trust something to luck and wait. So everything has to be done very precisely. So I'll say, if the traits required in a space engineer, technical competence. This is very much important, or at least the willingness to learn. See, you are put into a field, you have to study, or if you don't know, you can approach seniors and seek their advice, and you have to study. And technical competence is one area where there is no compromise. Then, in fact, if you find you have lack something and you require a training, we have a very efficient human resource department where you can put in which training or area you want to be trained, and that will be done. And communication is very important. You find a problem, you don't keep it. See, I told you, that 17 mm. 16 to 17 mm, that 1 mm difference was there, and they thought it was trivial. Don't talk to a senior, talk to somebody, at least around your people, saying that I found that it doesn't have an impact, or talk to the designer. So this is very important, communication, horizontal as well as vertical. Now, whatever I am saying that traits required in a space engineer is applicable to you, all engineers who work in any organization, because I think this is not specific to space alone. Now, decision making, this is very important. See, when you have to make some decisions, you don't make unilateral decisions. Decisions, you can take opinions from others, it should be a collective wisdom thing. But that doesn't mean you spend time, long time in making decisions. It has to be quick and fast, at the same time weighing all the pros and cons. Then why I'll help is the professional societies help. See, one thing is, when you are immersed in your work, you tend to forget, keep track of the latest developments happening. Now, in that, professional societies help a lot, because you come in contact with people working in different area, you listen to lectures, you have interactions, you talk to others, and that helps you think and apply new technologies or new trends in your area of work also. And managing multiple roles. This is very important, because sometimes you have to act as a manager, sometimes you have to act as a developer, and sometimes you have to act as a mentor to some of your juniors. Those things these are all required, and we have to have, you have to go along with it and carry it efficiently to be a successful space engineer. Now, how I entered the space arena, I never had any thought when I was small that I'll work in ISRO or anything. I had a very sheltered life. I was an only child. I studied in 𝗯𝗿𝗶𝗲𝗄𝗏 Convent in Trivandrum, and that did my pre-degree. Then during my engineering time, my father was transferred. So I went to Coimbatore and I studied there. And then I came back, because after my engineering, though I got placement in 2 areas, Mahindra and HCL, because in the 80s getting a job is very difficult, and PSG was one of the few colleges which had placement. But my parents did not allow me to go, because it was in outside. One was in Delhi, one was in Bombay. So I was forced to, said the only choice was given was Keltron or ISRO. So I joined Keltron. I was very worried, because I passed out in July. Though I should have gone and joined the thing, I was not allowed. I was forced to wait by my parents to see whether Keltron or ISRO is inviting applications. Keltron invited in November. I wrote the test and got in, and I was working in Keltron for a couple of years. Then ISRO advertisement came, and I applied again. And somehow I think that initial days, ISRO used to be catching a lot of importance in Trivandrum, because the first time we are seeing so many buses flying with all professional people, and we were thinking they were doing some great work. And every Wednesday there used to be a launch, the launch which I'm showing on the right hand side, where the small rockets used to be there, and I used to run up at 5 p.m. it used to be, and run up to the terrace to watch. So somehow that fascination lingered in my mind. That is what I think. That is because I was comfortable. I was married by the time I was in Keltron. I shouldn't have left Keltron, but I joined ISRO. I had some internship experience also. I appeared for the interview and I was selected. But once I joined, I never regretted, because it was highly rewarding and challenging. I joined in quality. This is something I want to tell. See, there is a tendency among people that only design work is good. See, with the design, what will happen? There has to be someone to fabricate, transfer your design into a product. So be it electronics, be it mechanical, or be it chemical, somewhere somebody has there to produce, someone has to test it, someone has to evaluate it, someone has to put it together, integration and final as a rocket or a product. So every aspect of it is important. So this is something I want to tell the youngsters. Don't be disheartened if you don't get any particular area of work, but in whichever area you work, try to excel. So that, see, at one point in my career, my director used to say, if Valsa says it is okay, then I'm convinced. So you should encourage or inculcate that much confidence to your management, that when you say it is right or wrong, or when you say something, it is correct. So that way, it was highly rewarding and challenging. And I still, I find it nostalgic to and I feel proud to have worked in an organization which is of national importance. Now, some pointers I wanted to say: as you grow up in your career, there might be subtle discrimination. Sometimes life is not always fair. I have also faced. In whatever job you go, please be prepared for it, but don't let it discourage you. Be open and willing to accept challenges and explore new avenues. This is something I have seen among some of my juniors. Sometimes a new job you give to them, oh, madam, I cannot do it. I don't know. See, you don't know, but learn. Try to learn it. Sometimes that might be the thing that will be chosen. So when you get new challenges or new avenues, don't say no. Please be willing to put in the extra. You might have to, it might be outside your comfort zone, but please be ready to put in extra effort. Now, coming to your job, be aware of your rights and don't let anyone crush you, your ambitions, dreams, and goals. Sometimes, you put in a lot of effort and you come out with a design, and when you take it to your seniors, oh, what is this design? This is not good. Don't be crushed by that. Still perseverance is very important. Continue with that. So always think I can find something else which will satisfy my boss, and be aware of your rights and don't let I think that it's a repetition, and you should never let your fears prevent you from doing what is right. Or you should always see, sometimes this is something I have faced with my juniors, because they come and say, oh madam, we have found a problem in this, but I'm afraid to say because the designer is so powerful, he'll fire me. Don't be frightened, because I'll always say, you state what is there in your report, and I'll be there to support you. So never violate from your conscience. Always stick to it, what is right and what is wrong. So I have come to the end of my talk. So this was the visionary's vision. He should be second to none in the application, and I think we have most of his aspirations are realized, and we are slotted for more challenging endeavors. Worldwide, there is renewed interest in human space flight, and we need to contribute our share with initial steps to keep our head high amongst. Now see, wherever you go, when I have been abroad for official also, people are appreciating India, because we do such a lot of things in a very cost-effective manner. And discussions and debates on interplanetary missions and heavy-duty launches are getting translated into executable project proposals. The future of space transportation in India is very bright, with possibilities of improvement in all scientific and engineering disciplines. So to ambitious youngsters, we used to say that sky is the limit. But now I will say in ISRO, space and even deep space is your limit. And all the best to all of you. Please try to, at least some of you who are listening will try to join ISRO, I hope, because there is an integrated centralized recruitment board where the test is there. I have been there in setting the questions as well as in taking interviews for the people. But I have seen Malayalis are very few. Mostly it used to be North Indians, and in South, Andhra people used to be dominating who used to clear the test and come. So please see that you also study well, because it's all based on gate models. Study well, try to join ISRO, and take part in a program of national importance. That's all. Thank you. If you have some questions, I'll take. I think it's 9:05, but quick questions can be done.
That was a wonderful session. Thank you, ma'am, for sharing your knowledge and experience with us. But before we get into the Q&A session, let's take a virtual photograph to capture this moment. So I would like to request you all to turn on your cameras and bring a beautiful smile to your face. And Tinoch to do the honors of clicking the picture for us.
Say 1, 2,
Okay,
3
ma'am.
before clicking.
Okay. So,
Otherwise, hey, like that, how long?
so let's take the picture. Okay, 3, 2, 1. Okay. Okay, guys. Thank you.
So if any quick questions are there, I can take. Otherwise, we'll say bye.
Thank you, everyone. Now let's move on to the Q&A session. If you have any queries regarding the topic, or if you have anything in general to ask the speaker, do feel free to unmute yourself and ask the question. You may also put your queries in the chat box.
Since nobody else is asking anything, I will just quickly say, of course, I know Valsa's background, and she was heading software reliability group in ASRO, and as she was referring to Narayanan, who was my boss also in TCS, and he was also heading quality group there. And incidentally, there is a commonality between Valsa and me on quality area also. Though I had a brief stint of 10 years only in ISRO, I was heading a national level standing committee for software evaluation. Unless I clear, those software will not be operationalized, even in remote sensing area.
Okay.
And same way, I was one of the contributors to, you may remember, ISRO Software Engineering Standards 1994 version.
ISES 92.
1994 version. I was one of the contributors for that.
Okay.
And Bhattacharya in configuration management group, VSSC used to participate there. And Sinha was there.
Sinha was there, yes.
PJ Bhatt was there.
PJ Bhatt, yeah.
And Paddy, the black, for identity I'm saying, Pad, because the common name. There is one S. Padmanabhan VSSC also.
Yeah.
So I was one of the countries. So quality is an area of my personal interest also, right? And it's a very, very important area. In fact, in TCS also because of its true experience, and as you said rightly, there is no area of work is bad. Every area of work is important. The way how we take up the job. Even after moving to private sector TCS, I was offered to head the quality group in Budapest. Hungary is a beautiful country, right? And, I had been to Budapest for other purposes, but this I could not go at that time for personal reasons. But what I say again, I will second what Valsa was telling. Quality is highly important area, and no area is less important as long as you take the work seriously. Thank you, Valsa. It was a remarkable session. I enjoyed it.
Thank you. Thank you, everyone. So I'm leaving. Bye, sir.
Thank you, madam.
Ma'am, am I audible?
Yeah.
Ma'am, can you please wait till the vote of thanks?
Okay, sure. Okay.
Yeah, she will give the last word, Valsa.
Yeah, she can have the last word.
Yeah.
Yeah, please go ahead.
Okay, ma'am, thank you. Now, as a token of appreciation from our side, we would like to present Dr. Dr. Valsa B with a virtual memento. For that, I would like to invite Mr. Ananthakrishnan to share the screen and present the virtual memento. Now, let's move on to the vote of thanks. For that, let's welcome Engineer Prabin Sir, Secretary, IEEE Education Society, Kerala Chapter.
Dear Dr. Valsa Madam, Bindu Ma'am, Lisa Madam, Sajin, Sharath, and other professional members and IEEE volunteers and student volunteers. Firstly, I thank Dr. Valsa Madam for conducting a wonderful talk on the ISRO and Vikram Sarabhai Space Center. I strongly believe that her valuable speech was fruitful for the IEEE volunteers as well as the IEEE members. His words are truly inspiring. Thank you, ma'am. And thank all the participants for attending this webinar. Thank you for all.
Okay.
Okay, thank you, madam.
Okay, I can leave now.
Good night. Good night.
Good night. Thank you.
Yes, ma'am. Sure. Thank you.
Okay. Good night.